What's on your playlist right now?
In my class.
Go to guilty pleasure food.
Ice cream.
Ice cream.
Hi, my name is David Gold, and I joined the Earth and Planetary Sciences Department at UC Davis in 2018. My lab focuses on geobiology, or the interface between the Earth and life. We take this theme in a variety of directions, though we generally center the research on marine invertebrates such as jellyfish and clams. I love this work because it can go in so many different directions. While my starting questions are about the origins of animal life, our projects touch on everything from climate change to biological aging. Davis has proven a great place to develop such an interdisciplinary program, and I'm thrilled to be working here.
So, David, welcome to Face to Face. Thanks for taking some time to join me.
Yeah, thank you for having me.
Tell me, when did you first know that you wanted to be a scientist? Did you have an aha moment, or were there a series of events? How did you get along this path?
It's a good question. I was one of those kids who loved dinosaurs. That's kind of where I began. That's what got me interested in science. And that's sort of where I think my blend of thinking about deep history, thinking about the fossil record, but also thinking about life and living organisms around us, that's really what got it started.
Did you watch any of the Jurassic Park movies?
Oh, I just took my mom to go see the new one. It was interesting.
I saw it as well. And we don't do movie reviews here, but I agree.
Yeah.
Understand that your research, investigates the evolution of animal life.
Yes.
And that you've won a career award from NSF. And for those that don't know in our audience, a career award is a high honor given to a young faculty member, a young researcher. UC Davis, I think we had about 18 of them, and you were one of them, and very proud of all our young faculty for those accolades. Can you tell me about that career award and how you got that?
Sure. I was very excited about that as well. So this award looks at, it's based on this idea of geochemistry, right? That we can look at the rocks and figure out what chemicals are in the rocks, and from there understand what kinds of life forms once existed. So when we think about fossils, right, we tend to think about bones and shells and hard parts, but there's all sorts of other molecules that can get preserved. And one of them, I learned about this work when I was a postdoctoral researcher at MIT, is that cholesterol and other kinds of fats or lipids can get preserved in rocks. And sometimes they can leave a kind of fossil even when everything else has decayed away. Right? So we look in the rocks and we might see that they're full of cholesterol or something related like that. And that tells us about certain life forms that were alive. And that can be informative for all sorts of work. People use it for doing remediation work, understanding pollution in the environment. But if you look at very, very ancient rocks, you can use these same tools to try to figure out when some of the earliest life forms evolved. And so that's the kind of grounding of this work, sort of the intervention. The thing that I'm bringing to it is thinking about genetics and combining genetic research with the fossil record. So often we find these molecules, but it can be very difficult to figure out who exactly produced these molecules. Many different living creatures today might make cholesterol, for example. Mm-hmm. And so by understanding the genetics behind it, which organisms make these molecules today, what genes are required to produce them, we can actually reconstruct the history of these groups and figure out essentially which group of living things evolved the genes necessary to make these molecules at what time, and start separating out different competing hypotheses of who produced what. And so that's kind of like the underpinnings of this research project.
That's fascinating. So I understand one of the life forms that you study that is the jellyfish.
Yes.
And what can a jellyfish teach us about the origin of animal life and about living longer, and maybe something you can help me with on de-aging, as I'm having this problem right now about aging?
I mean, jellyfish, I started working on them as part of my PhD research when I was at UCLA. And they're just fascinating animals, very, very weird, very simple animals, and I started studying them in part to understand their genetics, to understand what they are the living descendants of some of the earliest animals, some of the earliest animals that we know of. So they can teach us a lot about early animal life, but they just teach us a lot of basic biology. The more I study them and the more I understand their life cycle and mess around with them, the more things they do to surprise me. And so even though the initial research has been using jellyfish as a model to think about what genes the very earliest animals had and what they might have been capable of developing in terms of organs or eyes or nervous systems, there's actually a lot of work that I've been doing more recently thinking about what they might teach us about just basic aspects of how cells age, how they reproduce, because these animals, they go through multiple adult life stages. They have these remarkably complicated cycles where they spend part of their lives as little tiny sea anemones that essentially asexually clone themselves indefinitely, as far as we can tell.
Wow.
I've been raising the clones that we sequenced the genome of these jellyfish. They're a type of moon jellyfish that are found off the coast here. And we started this project sequencing their genome, my colleagues and I think in 2011 was when we began the work. And I've been keeping that same individual we collected the DNA from has been just dividing and dividing, and we have a whole colony of clones. And as far as we can tell, they're still dividing and still happy. Whereas then the other adult stage is the one we think of as a jellyfish, a medusa, and that's what swims around in the ocean. And those live for a year or two, maybe in the aquarium, and then they age the same way that not quite the same way you or I would, but they develop holes in their bells. They fall apart and they just, they lose energy and die off. And so we're really interested, what changes between those two life stages? And I've started to bring in more researchers to understand how essentially they turn this aging process on and off, and what sort of genetic and biological properties might be dictating it. And one of the really exciting things we're curious about is it looks like maybe under certain conditions, you can get that medusa stage to go back, to reverse back to being a polyp.
Wow.
And if that's the case, then these animals are essentially biologically immortal, and opens up just, again, I guess the last point I will say on it is that as we study their genetics, we're finding that most of the genes that you and I have, they have a copy as well. At the genetic level, they truly aren't that different. And so understanding which genes are allowing them to reverse their life cycle, postpone aging, deal with the cellular damage that occurs, that those might be things that we can apply to ourselves as well.
That is so interesting. I'm really interested to see how this work progresses. And speaking of differences, I really appreciate your commitment to inclusion in the work that you do. That's a passion of mine as well. So, and this is evidenced by your effort to recruit American Indian community members, college students, community college students to do the research at the Bodega Marine Lab this summer. Can you talk about how that's going?
Sure. That work, which is coming out of the Career Award, is still very early. I'm hoping to get that going officially starting this following summer. But I agree, it's really important. It's something that's been important to me, and something that obviously in post-2020 and the last few years I've really been reflecting on. I think my whole department, the Earth and Planetary Science department here at Davis, has done a lot of soul searching and discussion on. Something like paleontology, I got interested in it because of dinosaurs, but the reason it's in earth sciences is because that field has traditionally been very closely allied with fossil fuels, with resource collection and prospecting. And so there's a really long, unpleasant history of paleontology. And with resource dispossession. And part of what made me want to do this work specifically with the Native American communities here is that, in America, it was very closely allied. Traveling west to look for fossils with often just stealing resources and claiming resources and justifying taking it. So, it's something that I think I've seen sometimes people try to ignore it, say it's not related to the science today. But when I'm teaching my classes and when I'm working with students, I think the students respond much more when we acknowledge these things and acknowledge this history, and not just how it shaped history, but how it has shaped the science as well. And I think we'll do much better science when we are acknowledge these things and are more inclusive.
I agree, and kudos to you for making those connections to the science, to people and the science.
Thank you.
I'm very impressed by that. I want to play a little game with you now.
Okay.
It's easy. It's called Hot Seat. And I'm going to ask you some rapid-fire questions, and I'm looking for one word or one sentence, short answer to each of the questions. Ready?
Okay.
Here we go. So I know you've lived on both coasts now, so what's better, east or west?
West. No,
That's the right
question.
answer. Yeah. Who is your hero in the science world?
Oh, my hero in the science world. Sorry, you wanted a quick answer. So many of my heroes have let me down. I think it's best to there's people I intellectually like, but I try not to
Maybe from a science standpoint, not their personal life.
From a science standpoint, boy, you got me.
It's a hard one. You want to come back to it?
No, Stephen Jay Gould, paleontologist, evolutionary biologist at Harvard, had some real foibles as a person, but very important ideas and influenced me a lot.
Yeah,
with my
that's
early
good.
thinking.
It's so common that people that are very creative or have genius attributes also have some warts in their personal life and some issues. So, but thanks for that answer. You have a 3-year-old.
I do.
And what's the best place to take a toddler on our campus?
Oh, so right by the vet med school, there's a spot that's got cows, horses, goats, and llamas. I've gotten a lot of good time out of that.
We have our own zoo.
Absolutely.
So if you could be doing anything totally different with your life, what would it be?
I used to love drawing and animation. I did that a lot as a kid. Taking my dinosaur toys and moving them 1 inch at a time. I always thought that would be a lot of fun too. Fortunately, it's the science. As I've done more science, I've done less art. It's something I'd love to change.
We have that in common. I used to draw as well. I draw my comic book characters.
Oh, wonderful. There you go.
Yeah. I always ask this one to every guest. What's at the top of your playlist this week?
I've been honestly listening to a lot of, it's not my favorite rapper, but I've been listening to MF Doom a lot. Passed away in right at I guess it was New Year's Eve 2020. They announced he had passed away, and it's just kind of been it was a cruddy end to a cruddy year. Seems to keep coming back.
Indeed. Well, now that's great. Now it's your turn. You can ask me a question or questions. Ask me anything.
Sure. This one. So one of my first lab members, when we're talking about these issues of diversity, one of my first lab members was a dreamer, and I'd known her for a while, and she was my lab technician. She did a wonderful job, but her goal was to go to dental school. And this was sort of a placeholder, because as a dreamer, it was just very unclear whether she was going to be able to go to dental school or not, or whether the rules would change after a few years. And now she's at UC San Francisco at dental school, so it's just wonderful now. But it certainly has gotten me thinking, that we're clearly at a time in America where I think there's going to be a lot of variation between states on how people deal with, obviously, not just immigration, but given today, with reproductive rights, with citizens' rights, with all sorts of rights. And I just wonder, something I've wrestled with, and I wonder is how do we kind of protect our community here in California and in the UC system, but then also how do we relate to universities and states that might have a different idea? Great question.
You may know we have probably 700 or so undocumented students on our campus. When the previous administration rescinded the DACA program, we were very aggressive in our advocacy against that policy. I wrote an op-ed, and we wrote to various elected officials to help us, and the university itself sued the administration and won. And so we're pretty active in this area in supporting those students. With respect to how we can do broader work for states that may have different perspectives, we are active in organizations like the Association of Public and Land Grant Universities, APLU. I'm now chair of the board. And we're also active in the AAU, American Association of Universities, and many other organizations. But those organizations often not only take positions on these issues for the university constituencies around the country, but also do advocacy in Washington. So issues like immigration and some of the others that you mentioned, I can imagine APLU and AAU and others being pretty active in taking positions, what we think are the right positions on these issues and advocating in Washington. So it won't just be for California, it'll be for our whole higher ed community. So
it's wonderful. Mm-hmm. Yeah, and if I can ask another question, because obviously something else that's been important to me, as you said, I've got a 3-year-old, and I must say the last couple of years have been a real challenge starting a new job and starting a career with a new child. Not having really any family or resources around, it led to a lot of passing the baby back and forth, and I would be in my pajamas and my button down doing Zoom classes, for a year or so, but we're trying to get back together. And so it wasn't just me. I know a lot of families here on campus with young children who've struggled a lot the last few years. And I'm just wondering what we can do as a community, or if there's any thoughts about what can be done to maybe help bring things back to normal, or ideally make things a little better when it comes to child care.
Yeah, great question. And first, congratulations to you for getting through it. My sympathies for having to go through it with a young child. I guess the first piece of good news is that now we have vaccines for those children of that age and school-age children. So that will be a very positive development. I think that when we were going through this the past couple of years, we tried to make all accommodations we could in collaboration with the Academic Senate, who has the jurisdiction for policy with respect to how courses are delivered. We're also actively thinking about how we can have opportunities for our faculty that had those challenges to sort of make up for the things they missed during that part of their careers, or be able to have that accounted for in tenure and promotion and other activities. I'll also say that we've been, on a longer-term basis, we've been thinking about child care facilities. We actually have an agreement with SMUD and others in Sacramento to have an on-site child care facility, and we're looking at expanding that even further through Aggie Square and some of the things we're doing in Sacramento. Not as much locally here in Davis, but we're still thinking about that and looking at it. But we're certainly open to any recommendations, suggestions that people that are in your situation can help us with in trying to make your career successful in spite of some of the challenges having a young child, because we want you to be happy as a scientist. We also want you to be happy as a parent and a member of the community. So,
well, thank you. That sounds wonderful.
Great. Well, David, thanks for being here. I learned a lot today. I learned that my cholesterol might last millennia beyond me. And I think your work is fascinating, and I'm so glad you're a part of our university community. And thanks to everyone out there watching. We will see you next time on Face to Face. Go Ags.